In this video, we are talking about solving systems of linear equations using our good friend, the graphing calculator. And we are using some technology that's not just graphs or tables. We talked about that a little bit before. But in this case, we're going to talk about how to use matrix applications or matrices to solve these systems of linear equations. So we're focusing on equations that have more than two variables. And in this case, we're going to look at three variables, but you could do this with more than that. What you want to do is choose a system that has, a few variables in it. And we are going to, I'm going to give you an example of a system that would be appropriate here. So let me move this way for this case, okay? Actually, I'm going to pause and readjust. Okay, so this would be a good system to look at. Now notice that this system has three variables in it. And in this system, we have all your x's are aligned. You see them? They are all in the first position here. And then we have all our y's. And then we have all our z's. Oops, sorry, z's. And on the other side of the equal sign, now that's important, your constants are on the other side. Okay, so what you're going to do with this is you're going to take a minute and write down all the coefficients of the variables in the order that they occur, as well as the constants. Okay, and what you get when you do that looks like this. Okay, so you see you've got a matrix, which is just a rectangular block of numbers, do you see? And we just have the coefficients of the x's, the coefficients of the y's, the coefficients of the z's here, and then the constants here. Okay, and so this is where we use our technology, and it's really, really, really easy. Okay, so let me walk you through that. Grab your handy-dandy calculator, power it up, treat it really nicely, and it will treat you nicely too. Okay, so we are going to go to our matrix menu, and matrix is over the inverse key, so we're going to do matrix right here. Okay, and I have mine set up so it's just going to create a matrix. Well, to create any matrix, you're just going to cursor over to edit, and when you press edit, enter, you can tell it how big you want your matrix. Now we want a matrix that is 3 rows by 4 columns wide. Okay, so we say 3 by 4. Your number of rows comes first, your number of columns comes second, and that dictates how large, or the dimensions of your matrix. Okay, so I have put this in for matrix A, a 3 by 4 matrix, and I have put the coefficients in the correct positions. 6, 3, 5, and you can't see, but 6, 3, 5, and if I go to the next position, -1, it'll take us all the way through that row. It will only show you 3 positions at a time. Okay, so go ahead and put all those numbers in. Yippee skippy. Got them all in. Yay. Okay. And then we're going to quit. So second mode, which is going to quit. Okay, so now I have my matrix in my calculator the way I want it. So the next thing I'm going to do then is ask my calculator nicely, with a nice tone, with a little bit of a please on it, to take that matrix and do what's called convert it to reduced row echelon form. Okay, so I'm going to go back to my matrix menu, and we're going to hit the math button. And there's a lot of different things I can do with matrices here. Okay, find the determinant, do a transpose, you know, all kinds of good things. But we're going to cursor all the way down to when we see not REF, which is row echelon form, but RREF, which is reduced row echelon form, which is option B. Yay. Okay, so I'm going to press enter. And this is saying, please put matrix what in reduced row echelon form. So I need to go back and tell the calculator that I'm interested in matrix A. So go back here and press A, enter. Okay, now it's saying please put matrix A in reduced row echelon form. So now press enter, and it gives me a matrix with a bunch of zeros and ones. And I'm going to do this nice little trick and turn what I have here into fractions. The math trick, math fraction, and enter. And now my matrix has fractions instead of decimal approximations. Okay, so this matrix with all the zeros and ones actually gives us the solution, or the ordered triple, to the equation system that I started with. Okay, so that first row, x is equal to 1/2. That second row, y is equal to 1/3. And that third row, z is equal to -1.